Right. Hi, I'm Ritik, and today let's talk about hyperparameter optimization with GridSearchCV. Quite a mouthful. So let's break down the title: Hyperparameter Optimization with GridSearchCV. So first, hyperparameter. Let's talk about hyperparameter. So what is a hyperparameter? Well, it's a characteristic of a model that is external to the model and whose value cannot be estimated from the data. Right. So what does a model do? Some X features, a Y label, computer functions as that the X features, some maths in between, and we get the Y label, right? But there are some characteristics about the model which we cannot estimate with the data. For that, we need hyperparameters. The value of a hyperparameter has to be set before the learning process begins. For example, k and k nearest neighbors, how many neighbors you should consider before finding the Euclidean or Manhattan, whatever distance. Depth of a decision tree, well, it helps in avoiding overfitting of a decision tree model. Learning rate of gradient descent, how much you are jumping over the cost curve. The number of layers in a neural network, how deep the neural network will be. So these things we cannot really figure out with the data. The user has to set it themselves before the training begins. Right. So we'll start with importing all the necessary libraries and the dataset. We'll need Seaborn, NumPy, Pandas. We'll use the most basic k nearest neighbor classifier, and we'll scale the data, of course. We'll split the data set into train and test spreads and the grid search algorithm. Right. So let's import the data set. Let's have a look at it. So this is our data set, the classic old school iris data set. 4 features, one label, 150 examples. So let's have an in-depth look at it. Right, so here's a pair plot. So if you notice, you can see that uh, all the different labels, all the different categories, all the different irises, they are clearly separated mostly, but they are clearly separated, and you can train a model to find out if a new point appears, a new iris appears, where would it fit in these. Right, so first we'll preprocess the data, we'll scale it and remove the data and the label separately, because I mean, what's the point of giving your model the label column, right? So we'll start with the most basic one. Let's go with one neighbor first. The nearest, the absolute nearest neighbor. You figure out with that one which class the model belongs to. So we set the number of neighbor parameters to 1, and boom, wow. So we have 100% accuracy on the training data, more or less it has memorized the data set. But the tested accuracy is terrible. It's 89%, absolutely unacceptable. And worse than that is the delta between these two. So that's kind of massive and unacceptable. So obviously this model is overfitting. Overfitting as in, as I said, it has literally memorized the data set. So it's like way too nicely it works on the training data, but crap on any real world data, that we cannot accept. Because of course when you deploy this model, it won't see the training set again, it would see some random real world data. So you need to optimize it for that. So let's say one neighbor clearly doesn't work, we have figured it out. Next we'll go with 3, the logical next choice. Right, the delta has definitely reduced, but so has the training accuracy. So this tells us that the model is now underfitting in a way. I mean, it's not perfectly optimized for the training dataset itself. Forget the test dataset, but still, it's a lot better. It has generalized a lot better to the real world data. So 3 works, but well, I mean, I can go on forever. As we have seen, there are 150 examples. So do I try change these parameters all by myself manually up to 1, 3, 5, 7, up to 150, well, that's gonna take forever. And I'm super lazy, can't do that. So instead, we have an algorithm, GridSearchCV. It's essentially a for loop on steroids. So GridSearchCV. Okay. On the CV part first. So CV stands for cross validation. Validation as in, I mean, sure, this test set data we are just using to identify if a model how it performs in the real world data, but we also need to figure out the hyperparameters, and for that we'll keep out a separate set. Let's call it the validation data set. So that will tell us how does the that will help us optimize the model even further. So I mean, and there's no hard and fast way to divide a training set into specific columns. Like if you take the first 20%, what if it is skewed towards one category? So that's going to give you crazy results. So instead, we'll try them all. So this is how cross validation works. The default by default we have five-fold cross validation in grid search. So we'll stick to that. Let's keep it as simple as possible. So the first fold, it's the first 20% of the dataset. It's kept aside for validation. The rest four are used for training, and this is used for validation. Later on, all the results of all these models are combined together and presented, and then we use them on our test data. Right. So again, we'll use the KNN classifier. Now, as I said, the neighbors can, and the number of neighbors we can use here, they can range from 1 to 150 examples that we had here, but we have kept aside a part of the data set for training, so we'll exclude that. We'll use the X-train dataset that is currently the 25% part of 150, so around 112. And out of that, since here you can see by default it takes around 1/5 of the part is saved for cross validation, validation. So 4/5 of it we have for training, so we'll use that, and plus one, because that's how the range function works. It doesn't take the last value. To include that, we'll add plus one. So we are checking for everything, right from one neighbor to 89 neighbors. That is the maximum number of neighbors it has available in the dataset. And then yeah, the GridSearchCV algorithm for estimator will pass this model. Currently just one model. We are concentrating on how many neighbors we want instead of the which model performs best. So we pass on the dictionary. The n neighbors parameter is set to number of neighbors. The the main parameter for KNN classifier. Number of jobs is set to -1, and figure out since okay now the number of neighbors, like let's say three neighbors and five neighbors. The three neighbor model has nothing to do with the five neighbor model, so you could train them parallelly, and that would help. That would increase the efficiency. So sklearn figures it out by itself how many threads it should create. So we'll set that to -1. And verbose one will give us a bit more information, and then we fit it on same training data. So we'll do that. Right, as I said, 89 candidates we have. 12 concurrent workers because I have a 12 core processor. So right, 445 tasks, and we have on this. Right, so the grid search module is essentially a brute force approach. Try everything and choose the best one. So here it tells us the best estimate, the best n neighbors value should be 13. That's going to give you the best possible training accuracy and testing accuracy. So we'll take that. We have tried everything. It doesn't get better than this. We have this module has proved it. So we'll set our n neighbors module that 13, that is, and then we'll try again. Right. So our training accuracy has gone up. That's great. Our testing accuracy has gone up as well. And we have proved with this given data, this is the absolute best model we can come up with. It doesn't get any better. So yeah, so the only way to improve your model further would be to add even more data. There's nothing more a person can do with this amount of data to get a better model. So yeah, that's it, guys. I've been Ritik, and this is GridSearchCV. Thank you.